I've got a microphone here, so it's fine. Okay, good morning, everybody. Thank you very much for the welcome. I'm just going to turn this on. I hope you can see at the back. I'm afraid this is all it is. I'm just this big, so I'll try and make myself visible. It's great to have the opportunity to open this session on quantitative risk analysis. What I want to do today, in my half an hour or so, and leaving some time for questions, is to give you something of a thought leadership, slightly stretching position piece about one of the applications of quantitative risk analysis that you might not have thought about. And so what the idea in my presentation is to answer these two key questions, which have been troubling me ever since I started working on risk analysis, which I guess was about 1984. I was about 6 at the time. I met Peter Simon in 1985. I think he was about 8. Actually, you're younger than me, Peter, aren't you? So, but it was a long time ago. And so I was doing risk analysis in a major engineering company, and we went through, did the workshops and various things, and the boss said, so how risky is this project? And I said, well, we've got 10 red risks, and we've got 22 yellow risks, and we've got 35 green risks. And so he said, and how risky is the project? And I went, I'll get back to you. Because that doesn't answer the question to give you a list of risks in the risk register. And so I started thinking about that really interesting problem very early on in my work as a risk specialist. And I think we've come up with an idea that gives you the answer. So how do we answer these questions? How risky is your project? And then what can we do about it? There are two levels at which we can answer the question. Let's get that arrow off there. So one, for the project manager, one of the things the project manager needs to know about is what are the risks in my project? And where do I look for those? We find those in the risk register, and we include them, we describe them in our risk reports. We talk about the top 10 risks and about trends in the number of risks in red, yellow and green categories, or high, medium and low priority, and so on. So that's where we answer the question about individual risks. But that's not the answer to the other question, how risky is your project, which is something that the project owner, the project sponsor, or the customer or client is going to want to know. And the answer is not a list of risks, or even a risk map with some kind of distribution that you get a kind of sense from looking at how risky the project is. There's a concept which is not the risks in the project, but the risk of the project. And they're quite different. So this idea of overall riskiness, we've come up with a term. When I say we, it's not just my own idea. This is some of the sort of the thinkers in the industry, and we've captured these, as you'll see in a moment, in some of the leading guidelines. We call it overall project risk, overall as distinct from individuals. So what is overall project risk? If we look for some definitions, the APM first defined this in the second edition of the PRAM guide over 10 years ago. And it's also described in the latest edition of the APM body of knowledge. So an uncertain event or set of circumstances that, should it occur, will have an effect on objectives. That's individual risk. PMI has something very similar, both in the latest PMBOK guide, the Project Management Body of Knowledge, Chapter 11, but also in the practice standard, uncertain event or condition, if it occurs, has positive and negative, blah, 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 blah. We know all that. That's individual risks. But also, in those documents, we also define this term called overall project risk. And if you've ever read the PRAM guide, or the APM body of knowledge, or the PMBOK guide, you should know this. So in the PRAM guide, we say that overall risk is the exposure of stakeholders to the consequences of variation in outcomes. And we say it arises from individual risks and other things, other sources of uncertainty, not just individual risks. PMI says the same thing, not surprisingly, since some of the same people were involved in these documents. The effect of uncertainty on the project as a whole. Now, you can't get that from your list of risks. It's not very easy. It's more than the sum of the individual risks on the project. Is this in scope for the project manager? Absolutely. We're responsible for identifying the risks in the project and reporting on those and for managing them effectively, the individual risks. But we're also accountable to the project sponsor and the stakeholders for the overall riskiness of the project. Is this project going to succeed or not? And that's the overall project risk. These are both our areas of interest in the world of project management, not just the list of risks and what we're doing about them. So how do we put together something about the list of individual risks that we get from our risk register and other sources of uncertainty, whatever they may be, to get a sense of how overall risky the project is? And that's what I'd like to address in this presentation. So obviously we need to identify where overall project risk comes from. We need to quantify it, respond, and report. In the time I've got available, I only want to just cover the two which are highlighted here because we're talking about quantitative risk analysis. How do we quantify the answer to the question, how risky is my project? And then how do we tell people about it? And I think those are the areas that we might find most interesting. But obviously, the other aspects are important as well, and there's a paper on my website which will describe some of those things. So let's get straight into quantification. That's, I know, what you're interested in. That's why we're here. Here we've got the two definitions, the kind of summary definitions from APM and PMI of overall project risk. It's the exposure of stakeholders to variation in the outcomes of the project. Is that good or bad? How much can they take? How big is it? And how big would they be comfortable with? It's also the effect of uncertainty on the project as a whole. So as a whole, we're then talking about overall project objectives, the ultimate end delivery date, the overall budget, the delivery of functionality, the satisfying of customer requirements. What's the effect of uncertainty on that as a whole? So we've got to find some way of synthesizing the individual risks and other sources of uncertainty to answer these questions. If we wanted to make them quantitative, numbers, then we could sort of distill those two aspects down to these two questions. In terms of the effect of uncertainty on the project as a whole, how likely is the project to succeed or fail? Which of course is the same thing. One is obviously the inverse of the other. And then the exposure of stakeholders to variation in outcome. Well, how much variation is there? When we have a target, could it be better or worse, and if so, by how much? And clearly, Monte Carlo simulation gives us the answer to these questions. That's why we should be interested in quantitative risk analysis, not just to say how much contingency do we need, although that's part of the answer to this question, not just to say which are the biggest risk drivers to the critical path or to the overall budget, but that's also important, but to give us a sense of overall how risky is my project, and then I can design overall project risk strategies to deal with the overall risk exposure. And I think this is an area that we've been missing for 10 years since we first put it in the PRAM guide, since we first put it in the PMI practice standard in 2009, and we said, hey guys, don't forget, our responsibility as risk specialists advising project people, or as project managers or program managers, is to answer the question for the stakeholder, how risky is the project and is that okay? And this is what I'm going to do about it. And we have the methodology, we have the tools and techniques to answer that question, we just haven't been doing it. So I hope at the beginning of today, what I'd like to do is to lift our thinking and remind us that there's a bigger context question, as well as the individual detailed things about putting individual risks into our project schedule or our project budget or a combined cost schedule, a project plan. We do that in order to say how risky is the project as a whole. So how are we going to do that? Well, let's look at an example output, just something very, very simple. This is a cost S-curve, and here we've got variation in the likely project budget. And there's an S-curve that says, you know, it could be that this is the probability of it being less than 2 million, right the way up to the probability of it being less than 2.8 million, and the probability obviously increases as we get a bigger overall budget. So you will see these sorts of curves coming on probably everybody's slide set from now on through the rest of the day. And from this kind of standard output from quantitative risk analysis, there's a number of important things we could learn. If our target was 2.2 million, then we can say, well, the chances of meeting that are about 23%. So we've immediately got some quantitative information which answers one of those questions: what's the probability of success? If we're aiming for this, the answer is 23%. We could also from this get a sense of the variation question. So if we took not the very extremes, because it's very unlikely we'll be right down here, and very unlikely we'll be right up there, but if we took a 5th to 95th percentile as a kind of a sensible, realistic range of potential variation, then the 5 to 95% point gives us this variation of about 500,000, from actually 2.1 to 2.6. That's a quantitative answer to an overall risk question. We can also say, what else can we get from this? We can get an expected value, the sort of average of all of these results. It's generally a little more than 50% because these things tend to be right skewed. So here we've got from this one, the expected value is 2.35 against a target of 2.2. And we could also read off, if we wanted to, target values and the corresponding probability of achieving them. So if we wanted to reset our budget target to something where there was an 85% chance of achieving it, we should do that at about 2.45. This is standard, all right, so far. But rather than just saying, you know, we've got all of these individual risks and other sources of uncertainty that we've ploughed into our risk model, and then we're just looking at how they affect what the risk drivers are and so on. What we can say from this is answering specifically our overall project risk questions. How risky is the project? And we can put numbers on it. So now we can report to our senior stakeholders, to our project sponsor, to our customer, and answer this question with numbers. So if we wanted the question, how likely is the project to succeed, we have a clear answer. On our current plan, with the risks, the threats and the opportunities that we currently know about and other sources of uncertainty, with the responses that we've already baked into the plan, there's a 23% chance of meeting the 2.2 million target. And we also know that the expected value, where we think we're going to come out on our current plan, is 7% over that. Now that's useful information in terms of how risky is the overall project. Our budget is at risk by at least 7%. That's what we expect on our current plan. And the other question, in terms of variation, we can take that 595 spread and say the range there is 500,000, which is 22% of the project value. So we're expecting to be 7% over, and the range on that is plus or minus 11%, 22%, which means that the very best case might be 4% under budget, but the worst case might be 18% over budget. Now these are useful numbers that we can start to have a discussion with our project sponsor or business owner about, because they're quantitative. They're not just, oh, there's a lot of red in my risk map. It's not there's just lots of risks on the list and what are we going to do about them. Now we have something which is about the overall risk exposure of the project budget. And obviously we could do the same. I was going to say schedule because my good friend David's here, but for schedule, it obviously depends what shul you went to.
Can I have a translation of that?
Yes, of course. So you could do the same for schedule. You could do an integrated model as well. But here we have, from our standard Monte Carlo output, a direct readout of overall project risk in quantitative terms. And these are the sorts of things we could, or we might say we should, be reporting to our project owner, our project sponsor. Very clear information. Okay, let's just have one other output which you might see from your quantitative risk analysis. I hope you do. And I'm going to use this because I'm going to come back to this towards the end of my presentation on reporting risk. Obviously, if we start our project at some point in time, we've not spent any money. And if we were to plot, then as time passes, how much money we expect to have spent, we could end up with one output that says a prediction of where we think we'll be in terms of cost and time. And of course, that's useless, isn't it? Just saying, well, here's our spot value, it's going to cost this much, it's going to take this long, that's our answer. The reality is there's a whole range of answers. And from our Monte Carlo simulation, we can get a range of possible answers of how much it will cost on this vertical dimension and how long it will take on this horizontal dimension. And it generally gives us this kind of scatter plot of potential results of variation in cost and time together from an integrated cost and time risk model, which I know some of the other speakers will talk about. And what we could do is draw some kind of best fit plot around this, which might be useful at some later point in time. And then we could say, how do we get from here, we haven't started yet and we haven't spent any money, to this range of possible outcomes? And we could say, well, there's a very best case where we spend the minimum, which is this value, so down the lowest of these dots here, and we take the shortest time, which is the leftmost of the dots. So to get to this point on the best fit ellipse is the best possible way to complete the project. And of course, there's a worst case, which is up on the top right-hand corner. This is where we take loads of time and spend loads of money. And then reality, what we expect is going to be somewhere in between and ends up with the expected value of this cluster of potential cost, time points. Now, my good friend David Hewlett, who you'll hear from at the end of the day, comes from the other side of the pond. For some reason, they call this a football plot. I've no idea why you would call it a football plot. We call it an eyeball plot, which is sort of much more obvious on this side. But, you know, over here it's rugby that's played by men with odd-shaped balls and not football.
Give me the football plot, and they said, wait a minute, football's round.
Exactly that. Well, it might be round, of course, but it usually isn't. So this is a standard output from integrated cost and time risk model. And I did my first one of these in 1984. This is not new. This is not clever. This is not sort of way advanced out there. This is a standard output of looking at the variation of cost and time together on our projects. And we should know how to do this. Why should we know how to do it? Well, it looks pretty. This is very impressive. But actually it gives us really useful information to report on, which I'll come back to in just a moment. Well, I'll come back to it now. So talking about reporting, what we want to do is to obviously tell people, once we've done this sort of analysis, what have we found and what does it mean? So obviously you don't just do your quantitative risk analysis once. We update it as we go along at key milestones or at key phase points or at key changes in the scope or major rework in the project. We rework our quantitative risk analysis because we want to know what is the overall risk exposure of the project at this point. And now we've changed this and now we've redirected in this way. And so we're monitoring the change, not just of individual risks as we go along, but the overall risk exposure of the project. And so as we do these updates, we should be talking to our stakeholders, our project sponsors, the business owner, maybe the customer, and saying this is the level of overall project risk using probability of success and variation around key targets. And then we can say this is what drives it, and David will come to this at the end of the day. And this is what we're going to do about it and what we have done. And this is where it's taking us. And this is where we're going to be next time I come back and talk to you. So it's really important that we tell people what we found because analysis must lead to action. The point of doing analysis is so that we can shape our project strategy and tactics in order to give ourselves the best chance of getting to the end where we want to be. So we're going to monitor changes and trends and we're going to tell people about them. Well, how? How do you tell people about changes in the probability of success and in the variation of your overall project outcomes? I don't think there are any standard reporting formats. I've never come across any. And I'm kind of looking at the speaker table and nobody's going, yeah, we've got those. So, you know, we kind of make stuff up, don't we? And that's what we thought leaders do. And so I've made a couple of things up that you might like. I'm just going to offer them to you, and if there's any suppliers in the room, then you might want to, you can borrow this. It's not copyright. So here are a couple of components you might like to think about. One is what I call the project risk barometer. Could have been a thermometer, but I thought I'd call it a barometer. So if we just said here, let's plot the, keep pressing, the probability of success, probability of project success from guaranteed failure to guaranteed success. And we might have some kind of zones where we said, if we're below a 50% probability of success, that's not so good. If we're in the west, we'll count that as red. Of course, in the east, they would think red is good and lucky and so on, but that's what we do over here. Red is a warning. So there's less than 50% chance of succeeding, bad news. If it's in that kind of 50 to 80%, well, okay, but what we really want to be is above an 80% chance of succeeding. And then what we can do is actually plot over time at our various review points and milestones how our probability of success is changing. This isn't really rocket science, is it? So we might say, well, when we do our first review, there's only something like a 15% chance of succeeding. But as we go through and we manage the risk on the project, this probability of success hopefully is increasing. Here we've got time now at review number 7, and we can see that we're into that, nearly into that green zone. There's about a 75% chance of succeeding. And if we were to do a kind of best fit trend line, it looks like we should be okay by the end of the project. So the barometer will give you that sense of plotting changes in our overall probability of success, either on project duration, project budget, or some kind of combined project performance parameter. Well, that's all right for the probability of success. What about variation? Well, we could actually put variability into this plot as well. And so what we do is we say if we're on target, that's kind of okay. What we really want to be is ahead of target. And if we're below target or over target, we're late or we're overspent, that's a problem. And so in addition to these kind of probability of success measures, we could also plot something here that says this is where we expect to be, best case and worst case. This is actually in kind of this dimension coming out, an S-curve, right? So you can see this is our 5% expected and 95 maybe. And we can say, well, this is where it was, oh dear, this isn't very good, but as time progresses, maybe we get a bit more variability in the middle, but it'll tighten up as we come towards the end. And now we're on the sort of expecting to be okay, which ties in with here, and the variability is tightening up. So we've got some kind of visual components of ways that we might report on this probability of success and overall variation. And you might like to consider something like this, and it will be very easy to produce those automatically from your software. Wouldn't it? Yes, David. Let me come back to the football plot. Oh, and a trend line on variability. The eyeball football plot, you remember this thing. What can we do with that? As I say, I started producing these in about 1984 or 5, and I thought they were very pretty, and I was very impressed when I first saw one. I think it might have been in one of your papers, actually, David. But then I thought, well, okay, so what good is it? You know, what can I do with this? And I realized that this best fit line was actually quite useful. So if we forget all the dots and the lines and the way that we got there, and we just focus on this end point, then if my target is to finish on this date and to finish with this budget, then that S-curve can tell me where I expect to, that best fit ellipse can tell me where I expect to be and how much off in terms of overall cost and overall time I expect to be, and what the range of variation is in both dimensions. So on my first review point, I might say, oh dear, you know, there's only a few of these results which actually fall at the target or within it. Most of them are on the wrong side. I'm in trouble. What we want to see is, how does this change with time? And I started plotting these ellipses as we went through the reviews in our projects 30 years ago. And I was able to show this kind of thing. Now we come back for another review. The ellipse has got smaller because there's less variability. We're managing the overall uncertainty in the project. And our expected value is getting closer to the target. And of course, what you want to see is as each review goes by, we get closer and closer to the target. Of course, what sometimes you see is it kind of wanders off into the middle distance, but that's obviously useful information as well. So the other dashboard components, the barometer with the variability, can give you information about individual milestones or individual budget targets or overall project cost or time. But here we've got something which is two-dimensional and will give us that two-dimensional information. The size of the ellipse is the variability in the project, and the distance of the spot, the expected spot from the target, is something about our probability of success or failure. And I've been doing these, as I say, for a long time. It's a very interesting sort of visual target as this is the kind of, you know, the focus point of the project, and you do actually see it wandering around quite a lot. We want to see it tightening in, and eventually it'll be a spot. We want it to be somewhere close to this one. So what can we do with these football plots? Well, the orientation of the plot, so the angle of the cost-time major axis of the ellipse, tells you something about the correlation between cost and time. So if you had an ellipse that was at 45 degrees, what it tells you is that as time goes up, cost goes up. They're positively correlated. It doesn't tell you which causes which, but they're correlated. And if it's in 45 degrees, it tells you they're more or less equally balanced. So when you get an increase in time, you get an increase in cost. There's obviously a scatter around these. So that's an interesting extra piece of information in terms of the type of risk that we're exposed to. And we could actually use that when we're plotting those variations in the ellipse as time goes by to see where it's taking us. So if we've got these, you know, cost and time are positively correlated, it goes up with a slope, and it's about 45 degrees, they're equally balanced. I've shown it here in the middle, but of course they could be anywhere around that kind of cost-time quadrant. Here we're underspent and late, or we're overspent and early, or we're sort of in a good place. It's the orientation we're looking at this time. Then actually we could think about other types of orientation. And in my projects I've seen all sorts. So here's one which says cost and time are negatively correlated. As time goes up, cost goes down. That's interesting. So it might be to do with our the way that we engage with our suppliers. It might be to do with the way that we release our resources. But this is an interesting case. Or maybe if we get a kind of more or less horizontal set of ellipses, it tells you that most of the risk is to time, because here's the variability. We don't get very much vertical variability. So it's really a time risk project. Or obviously, if the ellipse is more upright, then it's exposed to cost risk. So there's a number of really interesting things that we can get from these kind of very simple standard outputs from our project quantitative risk analysis. Okay, well, I want to leave some time for questions. So let me just wrap this up with a few thoughts about what we need to do as practitioners and maybe what the profession ought to be doing as well. We know in this room, in the APM Risk SIG, in PMI and other professional bodies, the Institute of Risk Management and so on, that risk is important. We wouldn't be here, we wouldn't want to know about it otherwise. But it matters at both the individual case, what are the biggest threats and the biggest opportunities, the worst things that might happen, the best things that might happen, and what we can do about it. But it also matters at the level of the overall project. How risky is the project? And what can I do about it at the overall project level? It matters. Both of these things, at the individual level and the overall level, need to be managed proactively, and we need to evolve our practice to cover both of them. Now, as I said right at the beginning, the good news is that the guidelines have been talking about this for 10 years. So there is guidance in the APM PRAM guide or in the PMI practice standard. The latest edition of the PMI PIMBOK guide, which I'm on the update team for, I'm the vice chair, it's coming out in September, has a lot more on how to manage overall project risk in Chapter 11 of the PIMBOK guide. So we are moving this forward, but we need to do it. And so the standards need to provide guidance, and those of us who are in practice need to implement it and show people how to do it. We have to deal with the risks in the project, but we also have to deal with the risk of the project. And depending on the audience that we're speaking to, then we need to be talking about both of these at different levels. So my final questions to you are these two. How risky is your project? How do you know? And what are you going to do about it once you find out? And if this isn't part of your overall thinking and practice, then maybe we do need to just modify and adjust the way that we approach risk management to include this really important bigger picture element. The information is available in our standard quantitative risk analysis outputs. We just need to think at that bigger picture level and then start talking about it. So I hope you found that useful. I will take, have I got time for questions, Keith? Is it 10 minutes or something like that? Yeah. So there's 10 minutes for questions, and I'll repeat the question back for the recording if anybody has any. But thank you for your attention.
First of all, can we put our hands together and just thank David for an interesting presentation.
Thank you.